Good morning, students. Today we are Good morning, students. Today we are going to start with the interpolation. So before starting to the interpolation, understand what is interpolation. Okay. So we are given a set of data points, and we have to find out the interpolation. So interpolation means we are finding out a function f of x, which will represent these data points. For example, we have 5 data points, value of x, and corresponding value of a function is given to us. For example, when x equal to 1, the function corresponds to 15. Let us say function is y equal to f of x, so it corresponds to 15. At 2 it is 28, 3 42, 460, and 581. So these points are known to us. So we are finding out the interpolation means we find out the function f of x. Okay, so that if we plot it, then all these data points will cross that function. So graphically we can plot it, and we can say we have interpolated these data points, or mathematically we can find out the equation y equal to f of x, and then we can plot it so that we can find out the value at any intermediate point in the given sets of point. Okay, say 1 to 5 we know, we can find out at 2.5, we can find out at 3.5, we can find out at 4.5, or any other point also. Okay, so this is what interpolation is. Suppose we have plotted this function graphically, then it is like this. Okay, at 1 it was 15, at 2 it was 28. So data points are known to us. Graphically we can plot it. So the simple function we have considered, and hence we can join all the lines. So this is the f of x function which is interpolated. But this is with the help of graphical interpolation. We will find out the statistical interpolation or mathematical interpolation by various methods. Okay, and the use of interpolation is we can find out the corresponding value of a function at any other data point. For example, we are interested to find it out at 2.5. We will take the point 2.5 on the function wherever it cuts the y-axis. So this corresponding to the y-axis, it is say 36. Then function value is 36 at 2.5. So this is what interpolation is. So in detail, we are going to study various methods of interpolation. So basically, there are say 3 to 4 methods are there. One is Newton's forward difference interpolation, Newton's backward difference interpolation, then central difference interpolation. So there is Bessel's and Stirling's formula for the central difference. Then there is Lagrange's interpolation. Okay, so all these 4 methods we can categorize into 2 types. One is equal step size and the other one is unequal step size. So if you observe these data points, the difference between the x0, let us say 1 is x0, 2 is x2, then x0, x1, x2, x3, x4. So if you observe the difference is equal. Okay, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So this is with equal step size, you can say. So when the step size is equal, we can go for Newton's forward or Newton's difference interpolation. Okay. Now, when to go for forward, when to go for backward, and when to go for central. So, if we are interested to find out at 1.5 function at 1.5 which is nearer to the starting value, then we'll follow the Newton's forward difference interpolation. If we are interested to find out at say 4.5 which is nearer to the end value, then we will follow the backward interpolation. Suppose we are interested to find out say 2.5 or 3.5, we will follow the central difference interpolation because we are interested to find out the values of a function nearby the center. So we will follow the central difference interpolation. So Stirling, Bessel's, Newton's forward, Newton difference, all are based on the equal step size. Okay, but now if the data points given are not at a difference of equal step size. For example, this is 1, then 2, then 4, 8, 10. So any step is there in between x0, x1, x2, x3, x4. Okay, suppose we call the step size as h. Then if this h is not same for all the data points, then we will go for say unequal step size method, which is Lagrange's interpolation. So formula is different according to the step size, and hence we can interpolate any function. Okay, so this is all about interpolation. What is interpolation? Which interpolation formula to be applied at which corresponding data points? Okay, that's all for this session. Thank you.